Assalamu alaikum, beautiful people. When I'm showing you the mistakes on construction sites, especially for RCC, beam, column, slab, etc. So many students, they are telling me, sir, every time you are showing us the mistakes on construction site. So what is the proper way, especially for reinforcement in beam column? So guys, now I will tell you what is the proper way for steel reinforcement, especially in beam and also in column. Guys, you can see this is RCC plinth beam, okay? So again, I'm telling you, this is wrong. So what is the proper way? Why it's wrong? Look at here. As I told you in many videos, and this is the reality, that concrete is weak in tension, but concrete is strong in compression. So what is tension zone? This is tension zone. The bottom steel rods we provide for tension, and top steel rods we provide for compression. As I told you, that concrete is strong in compression. Okay, when the concrete is strong in compression, so we should provide less amount of steel rods compared to bottom, because this is the tension zone. So in tension, you can see they provided 2 steel rods at the bottom and 3 at the top. So this is wrong. So what you can do? What is the proper way? The proper way is, if they are using 5 steel rods same like this, so they should provide 3 steel rods at the bottom. Here guys, you can see 2 steel rods. They should provide these 3 steel rods at the bottom and 2 at the top. It will be correct way. That's why, because in tension concrete is weak. So therefore, in tension we should use 3 steel rods or 4 steel rods. In compression, concrete it's strong in compression. Okay, so therefore we should provide 2 steel rods. So this is the correct way. Okay, so this is wrong because they provided 3 steel rods at the top and 2 at the bottom. But the correct way is provide 3 or 4 at the top and 2 or 4 or 3 at the bottom and 2 at the top, because top is compression zone, bottom is tension zone, and concrete is weak in tension. Therefore I'm telling you again and again. Okay, so now guys, the second one, I'm telling you there is a problem in stirrups. What is the problem? As I told you in many videos. So here guys, you can see what is the correct way. The correct way is, this stirrup should be placed with the spacing of minimum 2 inches. At this point they should provide, and after that to L by 4 distance. What is L by 4 mean? For example, you can see from this point to this one. Okay guys, so this is about 8 feet. Okay, so this is 8 feet. So L by 4 means to the spacing, to the length of 2 feet, they should provide the minimum spacing. But guys, you can see this is about 7 inches. They should provide with minimum spacing. Minimum spacing mean they should provide with 4 or 3 inches distance. Okay, so this stirrup should be placed at this point, 3 or 4 inches. This is the correct way. And after 2 feet, because L by 4 distance. Okay, so after 2 feet they can increase the distance between 2 stirrups at the mid. Okay, because why? What's the reason now? Okay, why we placed closely at this L by 4 distance? That's why, because at this place L by 4 distance we have more shear stresses. Near its support we have more shear stresses compared to its mid, because in its mid there is maximum bending moment, but here we have zero bending moment. Therefore here we have maximum shear stresses, and to avoid the cracks in beam, okay, cracks in column also, so we should avoid the cracks. By which method? To provide crank bar or extra bar, and also we will increase the amount of stirrups near L by 4 distance or L by 4 distance or near its support. Okay, so guys, you can see why it's wrong, because the spacing is equal, which is about 7 to 8 inches or 6 to 7 inches. Look at here. So this stirrup is okay. This is about 2 inches, as I told you here. You can see clearly guys. Okay, this is about 2 inches, and this is about, you can see about 4 to 5 inches. Okay, 4 inches. So this is the correct way. Now guys, come to its hooks. Guys, you can see this is wrong. What's the correct way? The correct way is, the hooks should be bent with 135 degrees, same like this at this point, like this, and its length should be minimum 3 inches. Okay, but this is wrong. They provided with 90 degree. As I told you in many videos, it should not be provided at 90 degree, but it should be provided with 135 degree. Now guys, you can see here This is wrong. This laping is wrong. Look at here. They provided the laping length here. Look at here. Clearly you can see. So this is not the correct way. As I told you, that the laping length should not be less than 45 to 50d, okay, or 60d. Till 60d you can keep, but here they just provided this is about 20 inches. Look at here, this laping is about 20 inches. Okay, so they should provide the proper formula, which is 45 to 55 60d they should provide. Okay, but this is not the place for laping length. Okay, so especially in tension zone, the laping should be provided at L by 5 distance. Okay, L by 5 distance. After L by 4 means after 2 feet they should provide the laping length, but they provide it in the L by 4 distance. Okay, so therefore it can make problem after some time. Okay, so it can be open. So this is wrong. In the proper ways, the laping should be provided L by 4 distance. After L by 4 distance means L by 5 to L by 6 distance. And also you can't provide at the mid of the beam or slab. That's why, because bending moment are maximum at the mid. Okay, and also shear force are maximum at the end. So where we can provide after L by 4 distance, maybe L by 5 or L by 6 distance you can provide. But at the top portion, especially for beam or in slab, the laping should be provided at the mid, but at the compression zone, not at the tension zone. Okay, so this is the other point. The laping should be not provide L by 4 distance or after L by 4 distance at the top. It should be provided at the top zone. For beam at the top zone, the laping should be provided at the mid, but not in tension member at the mid. It should be after L by 4 distance. This is also the other extra point for you people. So guys, today this is practical video to tell you steel reinforcement details practically. Look at here. Okay, so this is the proper way to provide steel reinforcement, especially for beam. Thanks for watching. See you in next video. Goodbye.